let's say you were given $67 million. Okay, and you were hey, you got to make a nuclear reactor that's fusion that is deployed for mining and also transmutation. Let's just say you got a contract at Fukushima. Fukushima has 132 million gallons of tritiated strontium-90 radiated water from their reactor that blew up in 2011. And someone gave you $67 million. What would the reactor look like to start treating that water? Like, what would it have in it? What would it look like? How big would it be?
Well, I know what part of it would look like immediately, because we've done experiments with this already where we know that we can use one of our reactor configurations to reduce concentrations of heavy radioactive elements. And we can pump the fluid through the reactors at a certain rate. It's a pretty low flow system. It's like 30 something gallons per hour that we can flow through it. We have to circulate it over time to make this reduce substantially. We have some optimization to do, but I bet we could fit this thing into probably an intermodal container that could be rolled up. And
what kind of size intermodal container would it be? Would it be like one of the smaller 20s footers, or would it be like a 40 footer or bigger? What would it be like?
Well, I wouldn't want to spend all of the money in one go, because you've got a business to set up and get running smoothly administratively. So I'd probably start a little bit smaller with like a 20-foot unit.
Okay.
And
so that would be like a milestone project.
Right. That would be an excellent milestone project, and also a platform for optimizing things. Because we've only run these tests so many times, because it's expensive to do setup.
Do you know how? Well, I can't actually disclose the number, but it's very expensive.
Yeah, it's pretty pricey per setup to do
radioactive waste.
Radioactive anything. When you start dealing with running water that has uranium,
poison,
right? Uranium in it. First of all, the people with uranium, you don't have a whole lot of people that are able to help you with those sorts of things.
Right.
So you have to do these things with a lot of care, and the inputs are expensive. The setups are expensive. You have to have very technically qualified people.
Oh yeah, certified.
And to manage this process for doing the experiment. But I'd say with that range of money, we could definitely get out a test unit and be running it.
Yeah.
And we already know that it's successful. We know it works. But that would give us the ability to set up and run, optimize, and be prepared to actually scale it.
Oh yeah.
And start deploying it to a lot of places, because we have a lot of sites. We have Fukushima. We have, in our own backyard, we have the Hanford site, where they have a lot of these similar water-bound goo or slurry,
weeping at the concrete,
or I think, and some of these are also just dirty water. It's not really like a slurry. It's not really like a high concentration of solid material in a lot of these cases.
A lot of it's just iodine, strontium-90, and cesium, and there's definitely uranium in there, because we actually tested the Columbia River water ourselves, and we detected it. So it's there.
Yeah, right. So that would be an amazing place to be. I'd love to have.
There's a lot of good golf over there.
I'd love to have tens of millions of dollars to play with. But that would get us a long ways. I'm very confident that we would quickly have a functioning
timeline. What do you think?
Functioning total package unit that would be pretty much plug and play. And we've gone through these mental exercises and done some of the initial design stages of that stuff already. And with my mechanical construction background, I have a pretty good understanding of the technical requirements and the likely timelines. Sourcing equipment, how to talk to people to get this thing put together in a smooth fashion.
We're so excited because you know how much
we're
money...
getting there bit by bit.
Do you know how much money the Japanese government has assessed that just the tank water, the tritiated tank water, is going to cost the government and the people over there in Japan?
It's like $220 what's that?
It's a
billion?
B.
Yeah, $220 billion.
$220 billion for that water. And the Government Accountability Office of America for Hanford, they've done a calculation independent study saying that the Hanford site itself could range anywhere between 220 to 660 billion, and they don't even know the timeline for when it's going to be done. And the same thing happened with the Japanese government. They said it's going to maybe cost 660 billion. So all government agencies that are talking about trying to clean up radioactive waste, they say the same number and they say the same thing. We don't know when it's going to be done because they don't have a solution yet. No, there is no solution except for this right here.
Yeah, this is the only solution we know of. The problem with that is all of these estimates of cost to the public for handling this waste is that these materials are not being changed, they're just being stored. And when that radioactive material destroys the container over time that it's stored within, it has to be put into a new container. So it's just this ongoing cycle of moving it from one place to the other, and then back again, and then back to the second spot, and then back to the original spot, and kind of shuffling it back and forth.
Sounds awful.
Because most of these, or actually, not most, but a huge amount of this radioactive waste is material that has half-lives in this range of millions and billions, thousands of years. We can't comprehend timelines like that, but they're present. So we for all practical purposes, these are forever materials that are just sitting there radiating away, and we have to shield it, and it destroys its container over time. So we just have to deal with these huge costs of going through that cycling.
Yeah, it's kind of a depressing thing to think about, that there is no solution. And I was just on the phone with one of our people that we work with who's very well knowledgeable about radioactive stuff and rad waste. He was saying that he was just recently at a conference, and the consensus is that nobody knows what to do. There is no solutions. It's just put a Band-Aid on.
I've got one.
Take a Band-Aid off, put another Band-Aid on, and I know Brighton and here at Quantum Kinetics, we're itching and ready to go. We want to make a difference.
Right.
And we want to save everyone. At the end of the day, everyone has to pay for that. Like our tax money goes to paying for that cleanup. And if it's going to be 300 years or 400 years to eventually get this cleaned up, that's going to be a lot of money out of your pockets. Like you won't even be able to go buy TVs that you want or buy a car or finance a car. Like what we're trying to do here at Quantum Kinetics, we're just give you guys solutions to big problems so that at the end of the day, you have more money in your bank account. It's really that simple. And we clean up the world at the same time. And the great thing about as we do the transmutation with this gravity negative field is that we're mining at the same time.
Right.
Whoa.
Yeah. I mean, we're getting
awesome
useful stuff out of the reactor as far as material as just a byproduct, which we have some control over already.
Oh yeah.
But when we have the chance to optimize it, we'll unavoidably get better at this.
What's crazy about, I'm sorry to interrupt you, but the really cool thing about the seawater of the treated water in Fukushima, it's ocean water. And when we put ocean water through our reactor, we get more sedimentation. Right. We get more mineral fabrication of like nickel, iron, aluminum, magnesium, silicon, all these crazy cool elements start showing up. Tungsten. At a rapid tungsten. Well, yeah, it's small. I mean, maybe it's small.
We've had some of that.
And it's just so there. It's it's basically this awesome sludge that you can dry, and then you have this metal there, compounded metal.
Right.
How awesome, man.
It's going to be a fun process working through the details of refining that stuff too, because that'll be able to be turned into a lot of useful stuff over time.